Welcome to the second recorded video for the Part A lecture notebook for the third module. We pick up with functions in Python. We start with some motivation. Now in the code snippets above, and to remind you, this is involving showing coding a 10 function for an activity and this other function that required some checks on the inputs before it was evaluated. In those types of codes, a value of x serves as the input into a conditional statement that determines what the output value of f should be assigned based on whatever the value of x was. Now imagine that you wanted to use that functionality many times in a code. What you would like to do is avoid writing these chunks of code over and over again throughout your script, your piece of code that you're using that is repeatedly using this functionality. That can often lead to errors. Even if you do copy and paste, that can lead to errors because you might update it in one place and forget to update it elsewhere. It just becomes a bit of a hassle and it makes the code very unwieldy and hard to manage. So what you would like to do is define a function name that you can refer to for that functionality, pass it parameters into the function. That would be the x value in the case above, but we'll see other examples of different types of parameters. Those are what the inputs are to the function, given whatever name you have. It has the colon, just like the if-else-if structure, and it has then the common indenting where you do the functionality, and then you might return the function value or other types of outputs, or maybe not return anything at all. There's something called a docstring that is optional inside any of your functions. And that is something that I describe here in terms of a brief discussion on docstrings and commenting in code. A docstring has triple tick marks on either side of it. You'll see some examples of it below. And it's really optional, but it's a good idea to document your code well, not just with code comments, but also docstrings attached to functions. And I'll show why, but the long and short of it is that it allows you to use the help function on your functions and output what the function's doing so that you don't necessarily have to go and investigate the inputs of the function every time, the contents of the function every time you want to use it. You could just look at some description of what the function's doing to make sure, yes, that is the function I want to use. Now you might say, well, I'm going to remember the functions I have, but eventually you might have a module, and you'll see in the Part C lecture notebook, a module will collect lots of functions that you would repeatedly use, and you might have a hard time keeping track of what all the different functions do and the differences between them as you start to make them more specialized. So it's just a good coding practice. I suggest you read this part carefully and look at the links that I'm providing just to give you more insight into the value of docstrings and what they can provide. And also, that type of habit and understanding how you can use tools to create great looking documentation for your code can give you an edge in a competitive job market. So it's a really sought after skill in industry. Now, parameters and keyword arguments in a function. This is a very important part of this lecture notebook. So in the definition of function, there is what is called a parameters variable. This is often a list of parameters as shown below. These are normally ordered unless you supplement them with keyword arguments in the function call. So at first, I will provide no keyword arguments. I will then show you how you provide keyword arguments when you're calling a function, and that's what happens here. You'll have to read the code comments in these examples to get a sense of how everything is working. And in that case, when you do keyword arguments, you can input the parameters in any order you want. Otherwise, they are treated as positional arguments, meaning that as you call the function, the order in which you assign the values, if you don't have any keywords associated with it, is the order that these x and y values are assigned. So let's just go ahead and see this example. Now, here is a docstring. Notice the 3 tick marks, and you can have multiple lines. So you could structure it however you want. So you could, if you press enter, notice the indenting here again, notice the colon, all these things are important. But you could have, lots of spacing in here, just a bunch of junk. I'm just showing anything between these 3 tick marks is technically a part of the docstring. And the docstring only occurs at the start of the function. So I'm going to get rid of that. And the point is, when you look at this function, rather than having to investigate this, and look at the contents and decipher what's going on, you could just read the docstring that summarizes, well, this is what the function does. Commonly in the docstring, you will explain the types of inputs that the function takes and the type of outputs to expect. And when you look at the source code for a lot of libraries that you would import for Python, and you look at the functions involved with that, they have extensive documentation in their docstrings. So it's a very important part of software engineering is proper documentation and use of docstrings. At any rate, myFun1, this is our my first function that we're going to investigate in this lecture notebook, has two parameters, x and y. This function returns x plus 2 times y if x is less than y. Otherwise, it returns x minus 2y. And you can see that's exactly what the code is doing. If x is less than y, we compute x plus 2 times y, and we assign it to the value to a variable z. Otherwise, else, we evaluate x minus 2 times y and assign that to z, and then we return z. Now, we could return nothing, in which case this computation takes place and nothing's ever returned. But we'll go ahead and run this now. And now, when I use the help function, for instance, on myFun1, look at what happens. It tells me exactly what's going on with this function. Now, you might say, well, I could just see it right here. I don't need this docstring. It's a simple enough function. True. But if you were later on in the notebook or in some other piece of code and you were forgetting what you had myFun1, myFun2, myFun3, you would probably make better use of this. This is just showing you an example of how you can use the help function. And your function might become really complicated, in which case it's better to have a good docstring than to have to read maybe 50, 100, 200 lines of code to decipher what the function's doing. You might want to have a nice summary here. I'm not going to dwell on that further other than to say it's really important in a lot of what I have you do throughout the rest of the course is add docstrings to functions that I provide and comments so that you get used to the practice of documenting and also having to interpret code and make sense of what it's doing. Because unfortunately, a lot of people do not follow good coding practice, and a lot of what you do in industry is cobble pieces of code together that other people have written to perform new functionality. And the first thing you do is take that existing code and the pieces of it and start to document it in ways that make sense to you so that you can put them together appropriately. But let's just go ahead and move on. Let's look at the outputs. We're going to print whatever this output of z is, this what we return from the function, when we give it 2 and 3 as positional arguments. So we say, well, the first parameter should be 2, the second one should be 3, which means we assign x a value of 2 and y a value of 3. Now, if you look at this, these are both integer types. And now I do float types on the second line. So when you think of casting back to the second module, you can probably guess at what the outputs will be. We know 2 is less than 3 in both cases. So this is the computation that should take place. And we should have 2 plus 2 times 3, which is 6. So 2 plus 6 is 8. So we should return a value of 8. But in this case, everything is an integer. And so when we look at the output, it is 8. And here, when it's 2.0 and 3.0, we see it's 8.0. It is a float. So this has to do with the casting that's automatically done with the arithmetic. This is just so that you can recall what you saw in the second module in the context here. Now look, if I switch the order of inputs, I now assign x a value of 3, y a value of 2. So 3 is not greater than 2. That's false. So it computes this, and we see, well, 3 minus 2 times 2, 4. 3 minus 4 is negative 1. This is exactly the output we see, negative 1.0. Again, it is a float. Now, this is an example of keyword arguments. This should be the same as this output. It should produce the same output as this. One value is an int, but one is a float. And remember, by casting, the more general of the two will be used. And so 2 is less than 3. We should get 8.0 again. And we're assigning x is 2, y is 3. So it should be just like this. And if we run it, that's exactly what happens. Now, because we used keywords, meaning we used the names of the parameters as they appear in the function definition, we can actually assign them in any order we want. We could say, well, y is 3 and x is 2. And even though we reverse the order, the output is exactly the same because of our keyword arguments. Now, you could say, what if I used what if I called it W? This would produce a type error because there is an unexpected keyword argument W. There is no parameter called W inside that function, so that would give you an error. I encourage you to try to break things and make sense of what the errors are. So I'm just giving you an example of how you might experiment and say, what would have happened if I'd give it some incorrect parameter name in my keyword arguments? Now, this code cell will produce an error on purpose. The reason is we use a keyword argument, but then we follow it with a positional argument. So we say x is equal to 2, and you can read this and you could understand in your human brain, well, y should be 3. The computer is not as smart as you. It is not as flexible in trying to interpret what is intended. So if you try to run this, you get an error, and it's a syntax error because it says there's a positional argument that follows a keyword argument. The message of this is, as soon as you decide that you're going to start using keyword arguments, you should really use keyword arguments everywhere. And you need at least keyword arguments to start following the first instance of a keyword argument. All other things need to be keyword arguments after it. You could use positional arguments. Like if I had this function had, let's say, 4 parameters. Let's say I had x, y, and maybe I had u and w, just as a for instance. Then you could use positional arguments for x and y, meaning you could just pass values, let's say 2 and 3. And then let's say you could make w equal to 7 and u equal to 4. You could do that following positional arguments of x and y. I'm going to leave you to explore that rather than make this video longer than necessary. But I just want you to think of ways you could experiment and ask certain questions about what will break, what will work, and because there's lots of ways in which things could break and work. Now, what I show here, because I've talked about casting, is we see that this function can take ints and floats as inputs. It might also take strings. You can say, how will that work? Well, let's see. If I run silly test as my x and y values, right? These are positional arguments because I don't have x equals or y equals showing up anywhere. Notice it says silly test. And you say, well, there's a silly with a space there and there's a test. Well, what did it do? So there's 2 of these tests and they were added. This is concatenation in strings. Somehow silly is deemed to be less than test. And then we took silly and added to it, concatenated because it's a string, 2 times test. Now we know from the second module that if you multiply an integer to a string, then it just creates replicates. It just puts these things together. It'll do multiple copies of that string. So you got test out of that, concatenated to silly, and it worked. Now, if we reverse the order of these, let's just see what happens. So there's test, and then I'm getting a lot of typos here as I'm doing this. Silly. Notice this gives a type error because you can't subtract strings. You can add strings because there's concatenation, but that's an unsupported type. So this is something that's a little bit weird going on with functions. It allows for very flexible types of inputs, but then sometimes it won't crash. It will give you outputs. Other times it might crash. It might give an error because it's just unexpected inputs. Like when you wrote this function and when I first presented this, you probably weren't thinking, oh, I would pass strings into this. You're probably thinking I would pass numbers. Well, there's no type checking going on in this function. And that's something that I talk about. I'll come back to finish the rest of this in a second, but that's what I discussed down below. This is to motivate what we're discussing here in terms of functions and type checking, about how you might want to check what's going on with the inputs of a function before you start computing things with the inputs that a function was given as its parameters, because you might want to avoid errors in your code and let the user know that the function wasn't designed to operate on certain types of inputs. But we'll just go ahead and we'll come back to that in a second. Looking ahead, this is what that was kind of showing there. I'm going to try to print the variable z. Now notice in all of these things so far, all of these calls to this function, I'm just printing the output. It's returning a value of z, but I'm never assigning the output of this function to any variable. So has z been assigned to anything? Let's see. If I print z, I see there's a name error. Z is not defined. And you could say, well, wait a minute. We're defining z inside this function. That's right. The value of z exists inside this function, and we return the value, but we never assign it to anything outside of that function environment. That is related to the idea of scope. So this is also setting the stage for material. I'm just going to scroll a little bit down below. involving, so it's kind of near the bottom here, about this thing called scope, which is best explored, I believe, in the context of in-place operators and pass by reference and pass by value. So we'll return to that in greater detail at the end of this lecture notebook, but I'm just showing kind of all the things that you should start to become aware of and see more of throughout this lecture notebook. Now, if I assign z the output of 2 and 3, which I know makes it 8, there it is, it's 8. If I run this function again with different inputs, 4 and 7, right, that returns a value of 18. Notice I didn't print an output, and so I'm just producing an output because I return a value of z. Now I return z. Here I made z equals 8. The question is, before I run this, think to yourself, do you think the value of z has changed? Is it still 8 or is it now 18? It is still 8 because we did not take this output and assign it to anything. The value of z in here is assigned only within the function. And whether or not we do anything with it outside of the function is kind of up to us. So since we're not assigning z to the output of this value of z was left unchanged. So again, that's just kind of setting the stage for other things that follow in this notebook. I just wanted to get your brain thinking about all the things that you might see as you run through this and watch this video. So let's talk about functions and type checking first. All right. As these code cells above demonstrated, Python does not type check the inputs and will attempt to perform operations on whatever is passed to a function. While that is useful in terms of flexibility, it can certainly cause some issues, and it may even cause some errors, as you saw when I, for instance, switched the order of Cilian tests. Like, you might not even want this function to operate on strings because you didn't maybe write it. I certainly didn't write it thinking I would want to pass it strings, but sometimes it works. And as I showed you, if I reverse test and Cili in their order, then it produces an error. So the output of the function becomes unreliable or unpredictable with certain types of inputs. So you can incorporate logic along with built-in function type at the beginning of a user-defined function to check if expected variable types were passed to a function before any computations are performed. Although a better approach is generally to use the isInstance function instead of a combination of logic and type to check variable types. Now, I provide a link here for the documentation, the official documentation of isInstance. And you can start doing Google searches and look for other examples of how to use isInstance. I'm going to show you something here. I'm not going to dwell on it further, but there's some other options as well that I give you, including looking back at your assignment part B, where you might do try commands based on certain types of inputs to just try to do different types of functionality on your code. Now, I'm going to go above here there we go, I'm going to insert this just to show you what isInstance does. So isInstance, let's say I try to check is Cili, like that could be my input, and I could check, is that a string? Yes, that is true. Is it an int? It is false. Is it a float? It is false. Now what about, let's say 2, is that a float? No, that is an int, right? So that is an int. That is true. So one of the things, I'm just trying to show you what isInstance produces. It produces a Boolean output of trues and false where you can check the type. Is something an instance of an int, a float, a string? So you might improve the functionality of your code, or let's say the predictability, by taking the function and modifying it. This is a good suggested exercise. So I might say, look, I want to check and say if, here's some logic, I maybe only want to operate on X and Y if they are either ints or floats, because those will give me the types of outputs I'm expecting. So I might check if isInstance X an int or isInstance X a float. And so notice the parentheses here. This is one statement with an or. I'll zoom in here. I'm checking if X is either an int or a float, and I will do the same thing for Y. I will check if it is an int or, I'll zoom out a little bit there, if it is a float. And then if it is, now I want to do this computation. So I'll indent that. And now, And then I return a z value if that's the case. Otherwise, I would print for the user, this function can only act on, or can only evaluate x and y variables that are either ints or float types. I'll say int or float types. So there's that new function. Scroll there. So now imagine with this instance, if I try 2 and 3, I'm hoping to return a value of 8. And notice, by the way, with this else, I return nothing. Nothing is returned by the function. So I can say, okay, print. I'm actually going to show this here just for the output. If I print this output, I print 8. All right. Now, if I do like a 2.0 and 3.0, that should do the 8.0. But now imagine that I give just one of these a string. I turn 2.0 into a string now. This function only can evaluate x and y variables that are either int or float types. It went through this and it printed that. Now notice this none because you're returning nothing. You're returning nothing from the function. So if I got rid of this print statement, all that you would see is this output from this print, and the type of variable that's returned, the output that's produced by this function in terms of what's returned is nothing, a none type. But this is printed within the function, right? So there's no return variable or value from the function if this part of the logic is pursued. So that just gives you an idea of how you might use isInstance in order to make sure that the types of evaluations you want to happen in the function are only occurring on the types of variables for which you wrote the function to work on. And you're preventing errors from being returned. And you're printing something useful for the user to say, hey, this function doesn't know, like, is not intended to evaluate variables of certain other types that the user produced for it. So that's just, I'm going to get rid of that. I suggest you write that. Try to pause this video, go back, do that yourself, play around with it, and then you can rewatch that part and check what you were doing against what I was just showing you. But moving on, we'll talk about some default parameter values. So one thing, there's some key points to this, is that Python allows you to set defaults within the parameter list of a function call. Defaults need to come after function parameters with non-default values. So if you have some function parameters that you do not want to set default values for, then you should put those before any parameters with default values. So you could imagine, maybe I want to evaluate that same function I showed before, myFun1. Now I call it myFun2. But imagine I say, look, typically I want y to be 2 for whatever reason. Let's just say that was the case. Then I would have x defined first just positionally, like I have a no default here. And then if I just pass nothing to the function, so I'm going to define that function, this will produce an error because x has no default value. So the function can't run. There is a type error. You're missing one positional argument for x. But if I run this, notice I'm just passing one value. This assigns 1 to x and it's using the default value for y because I'm not assigning anything to y. So now 1 is less than 2. This will run and it will give me 1 plus 2 times 2, which is 4, plus 1 is 5. And of course it'll be 5.0 because I'm passing 1.0. Now this is just the positional argument where I'm changing the value of y. I'm overriding the default value of y. So we'll do that right now. There's your 7, which makes sense. 1 plus 2 times 3, 6. 1 plus 6 is 7. And now I can again switch the order with keyword arguments. Y is 3 and x is 1 will produce the same output. But if I try to do, let's say this, I'll create a new cell. Maybe I try to do myFun2 and I just assign y equals to 1.0. This will again produce the type error because I'm not assigning anything to x. Okay, we'll get rid of that. Now, this last thing that I'm showing here is we can use a function outputs directly as inputs to another function. So I might take myFun2 with 1.0 as the x value. It's using the default value of y. And then that becomes the first argument. That'll become the x value that was in myFun1. And then the y value will be the output of myFun2 where I use x is 1, but instead of the default value of y, I use y equals 3. Now, I'm not going to run this here I want to just kind of move on, but I want you to think, like, go through it's fairly simple computations. Can you do these computations and work them out by hand or in your head and guess what the output of this should be? That's a good just mental exercise to make sure you can follow through the logic and what this output should be. Now, I have this activity, which is done before we get to this, where there will be another video. So this will be the end of the current video, is discussing what's going on in this activity. So this is a temperature converter function. You might want to use Google or your favorite search engine to look up how to convert Fahrenheit to Celsius and Celsius to Fahrenheit before you start doing this activity. Now, in this activity, I've got a lot of the code written for you. And the point of this function, you need to write a docstring here. Your docstring goes here. The idea of this function is to do one of the following. I'm assigning default values of none type to Fahrenheit and Celsius, F and C variables for this function. And the way this function is meant to proceed, look at this if structure here, is if you don't give it any temperatures, then it's just asking you like, well, why are you bothering me if you don't want me to do anything? Otherwise, the point of this function is to do the following. If a Fahrenheit value is given, but no Celsius, then it should convert the Fahrenheit to Celsius. And that's what you have to fill in here. If a Celsius is given, but not a Fahrenheit, then that means you need to convert Celsius to Fahrenheit. And now I actually wrote that out here so you could see it. This is what's going on here. You have to finish this part right here. And then if both a Fahrenheit and a Celsius is given, then the idea of the function is to check if these are really the same temperature, just given in different units, one in Fahrenheit and one in Celsius. And so here what it's doing is it takes the absolute value of the difference using the absolute value function within NumPy. And then you should look at what this does. What is that within NumPy? And it's related to, it's so that you can handle the finite precision arithmetic where there's rounding errors on the computer. And so it's just meant to be like, we don't need things to be zero. We need them to be very, very small to say that they're the same at like the computational level. So that's what this is, like a machine epsilon, effectively. So it's a very small value. So you could take that value and just print it for yourself and see how small it is. Now, let's read the actual instructions. You are to complete the code below that either converts a temperature given in Celsius to Fahrenheit, a temperature given in Fahrenheit to Celsius, or if two temperatures are given, meaning one is in Celsius and one is in Fahrenheit, it checks to see if they are the same. The part you have to complete, again, as I'm pointing out, is this part right here. You have to complete that. And notice I have a code comment. Complete this part. You should change the code comment once you've completed it. I also ask you to add a useful docstring to the function. Explain what the function's doing. Summarize it here, and you can use what I'm describing in this markdown cell for that. And then finally, you need to execute all these lines of code to make sure that they all run. And you can check these against an online temperature converter. They have them on Google and stuff to see if you're getting the right types of outputs. So that's the end of this part of the lecture notebook. And I will talk to you in the next video where we dive into the more complicated, subtle issues involving pass by reference, pass by value, and in-place operators. And we also talk about scope of variables inside of functions in here. So thanks for listening, and I'll talk to you in the next video.